static pat. Again, you've done this before. What does it mean? You don't have a pool, you only have one address. What? This 1.1. This .1. This is all you have. And that is what most of the companies have. Just one address, one leased line address from the internet. Right? But what you have also is some servers. Server number 1, number 2, and number 3. This is on the inside. These servers are on DMZ4, but these need to be accessed from where? From the internet, right? You're accessing some, so you're letting people use some services. Say this is telnet server. Now there's no such thing as a telnet server, but just so that we can practice it, we can see if it's working or not. Then the other one is HTTP. You also have, say, FTP. 3 servers hosted on the internet. Now you only have one address. How will you host this here? All three. I mean, there should be some way that people, when they use that address, they should come here. If they want to go to HTTP, they should come here. They want to go to FTP, they should come here. Say FTP is not here, it's here. On the outside, you only have one address, 150.1.20.1. How do you make this possible? You make this possible by using static. Statically, you will bind them. Obviously, it will be static. It won't be dynamic, because if it keeps changing, people on the outside will need to be updated every time. Hey, this port number changed. This port number changed. You'll actually bind these servers to port numbers here. You'll bind it to port numbers on that address on 150.1.20.1. Right? And also it's patting at the same time. If it's patting, that means inside can also go outside. Let's do that first. Let's start patting. Clear, configure static. So remove everything. Show run nat. Right? Let's do that. Static inside, not static. For patting is what? Nat. No, not nat. First I'll create global. Global outside 1 interface. Right? The pool is not the pool, it's an interface. And then global, not global, nat inside to the pool of 1, 0, 0. Anything coming from inside should be patted onto the pool. Let's see if it works. .20.10, right? It will use 20.10. It's not 1 here, it's 10. Because that is the address that the firewall has on the outside interface. So everything. If I come without the source interface, I'll still use 10. I'll still use 20.10. Good? It's easy to understand this, right? Now, I'm only doing for inside to outside. Now the thing is, on the same pat, on the same address, I need to assign some port numbers to these servers here. How do we do that? Let's go ahead and try on the PICs. Right? I'll say static DMZ3 to outside. Here I used to give an outside address, but now I'll say this is the only keyword that makes the difference. When you use the keyword either TCP or UDP, it's a port number, right? I'm binding port numbers. It converts it from static NAT to static PAT. TCP. Then specify the address. What? The outside address or the inside address? Here is which address? Outside address. High, low, low, high. Right? The outside address. What is the outside address? I only have one outside address. 20.10. But now I specify the port number. Now I specify the port number. I'll say on the outside, if someone comes on port number 23, bring him inside. Inside where? 3.3, port number 23 also. This is called port forwarding. This phenomenon is called port forwarding. What am I saying? Alright, it should use the interface command. So it's not the address, it's the interface. The outside interface with port number 23, and inside it should be 192.168 4.4, not 3.3. 4.4 for what? Telnet. It's not necessary that I use this on the outside. Here I can have anything, but this is the real address. In reality, it should be taken here. Let's try this first. Let's see if this works. Right? What am I basically saying? I'm saying if someone comes in here with the destination port number of 23, take him where? To this guy. What if he comes in through the same address with the port number of 80? Where should he be taken to? To the same 192.168.4.4, but on HTTP service. Right? Say I want a little bit of security now. I will not do port forwarding, I'll do port redirection. What do I mean by redirection? That means here I will not choose 80 for the outside port. I'll say 80-80. So for outside, he should not come to 80. He should come to what? 80-80. Let's try that. I'll say static. I used the wrong DMZ. This should be DMZ4, right? DMZ4. Then I'll also say static DMZ4 to outside TCP interface. Which port number? Outside port number 80-80. Inside address should be the same 4.4, but 80. I cannot do 80-80 here because there is no such thing as 80-80 on the inside. There is no service running on 80-80. Enter. Let's go to R4 and enable it as a both. Both telnet as well as HTTP. But will my packet go? If I go in from here, will it go? It won't. Why? Access list, out to in. Out to in. Now I want you to tell me exactly what that access list is going to be. Tell me. I want the exact match. Access list, whatever, INF. Permit what? TCP. Source. Any. It's the internet, right? Destination. Destination. How's the packet gonna come in? The packet is gonna be a huge one now. From the outside it's coming, right? Say 200 dot. What is the source port going to be? A random number. The packet is generated from the outside. It's coming in to use the service, right? What is the source? What is the destination address going to be? Port number? He's going to come and add this outside 150.1.20.1, not 110. Port number 88. Right? That is what I represented it on the outside. So the access list should see here. What are the checks? What is the first check? The second is security. The first is obviously the connection. There is no connection in this case because it's coming from outside to inside. Then there is NAT. Then connection state is set up. Then there is route lookup. Right? then there is route lookup. The packet is coming back in. Where is it stopped if there is no ACL? On the security check. So I need to bypass the security check and take it to NAT. Keep this in mind, because 8.4, this is the only thing that is different. 8.4, this is different. In that case, this box is replaced from there, it's put here in front of everything. But let's not go there right now, just concentrate here. So the access list is checked first. So what do I allow in the access list? What source? Any. Destination should be what? 20.10 and port number 8080. 8080, not 8080. Because he's gonna come in with port number 8080. So then I pass him, he goes security check, is bypassed obviously, so he goes to NAT. NAT changes this part to what? 192.168.4.4 and port number he changes to. That's how he goes here. If you mess this inside port number, he will not be able to access this service. The inside port number should be a standard one. The outside can be anything. But the problem here is everyone who's coming in, you have to tell your students or whatever, your employees, that do not come in on port number 80, come in on 8080. You have to tell them that. Right? That is an added layer of security. Go out. So tomorrow if someone tries to attack you, he will not know your web server is running on 8080. They'll try 80. But there will be no response because there is no port 80. The firewall will stop the packets. Right? TCP any? Host, not host. Yeah, host. 192.168. No. 150.1.20.10 equal to 8080 and also 23. There's two, right? One to telnet server and one to the 80 server. I have two commands. Right? I have two static commands. So I have to allow both. That one as well as this one. Telnet also as well as www also. Right? Apply this list. Access group INF in interface. Let's try if it works. R2. From R2. What do I telnet? 20.10. The interface address. Port number. If I don't put any port number, I'll go straight to R4 because 23 is mapped onto 23, port forwarding. But if I put port number 80, will it work? If I put port 80, will it work? It will not work. 80 will not work. 80 will not work. You'll have to put in, right? Same address, same outside address, 20.10. Different port numbers take you different places. I also want this to work. I'll have FTP here, also a telnet here. Also a telnet here. Right? So a different telnet server here, a different telnet server here. Can I map this also to 23 outside? No. I'll need to have a different outside port number for this. Right? I cannot have the same 23. One port number can take me to one. So I'll do that also for him. What? Tell me the commands. Not the access list first. First static. Static what? DMZ 3 to outside, then TCP, then interface, port number. Now for I cannot use 23, I'm already using 23. I'll say 2300. Inside is what? 3.3 and inside port number is 23. For FTP I'll use 21. TCP is there. Access list, the same access list I'll have to add more lines. Permit TCP any to host. Which host? Same host. They'll come to the same host, but only the only difference is one will come at 2300. He will also come in at 21. So I'm opening 4 ports on my access list: 2300, 8080, 23 and 21. I'm not opening 80. 80 on my access list is not open. 23, 2300, 8080 and 21. Right? FTP, telnet, telnet and HTTP. This is mapped to 8080. This is mapped to, let me write them down here. This is mapped to 8080. This is mapped to 23. This is mapped to 21. And this is mapped to what? What is this mapped to? 23. So if you go in 2300, you will go here. If you go in 21, you will go here. You will go 23, you will go here. 8080, you will go here. These are all port numbers of which address? 20.10. Good? Let's try. Same from R2. Now I will not use 23, I'll use 23. Where should I go? The problem with R3 is I changed a lot of things on there, so I'll need to bring it back up again. There's nothing on here. I need to create that loop back again. Although I don't need it here, I'll need it later. Also need a default gateway. Right? Let's try. I'm going where? R3. If I use 23, I'll go to R4. 2300 is taking me to R3, 23 is taking me to R4. 21 I cannot check. There's no FTP server running on R1. Good. What is this called? Static PAT. It's called static PAT. Static port address translation. Dynamic PAT you did is just interface, global outside interface, and everything is done automatically. Right? Let's check the connection table. Outside to inside, the port numbers are right here. The original port number and the random port number which was used on the outside. Right? It was changed. Remember, connection entry is checked after the natting takes place. Right? It's done after your natting. Not checked, created. Packet comes in, is ACL security check. I did this in the yesterday's video. ACL security check, NAT. After that, connection table is created so that the return path can be done. So that's why he has the original address in 23, not 2300. Okay, good enough. The last two that you're left with is which one? We are done with dynamic this, combo we are done, NAT control we are done, identity exemption we are done, static NAT we are done, destination NAT we are done, static PAT we are done, policy NAT and ER instructor. Policy NAT we have also done, but just to understand the concept once again, let's have a look at this scenario. The scenario says you have PICs here connected to your company. Your company has 2 servers. Right? This server is same subnet 1.0. This is .1. This is .2. This PICs is connected to the internet, and on the internet there are 2 companies. One is this, the other is this, also connected using the firewall, right? And they have something here, say servers, and they have something here called, say, servers. Now what happens is, this is 200, This is 100.1 public addresses, two different public addresses. This server, when it goes out of the PICs, he has a separate address, say 150.1.20.200, and this guy has a separate address 150.1.20. Also 20. Same subnet dot say this is 100. Why? Because there are two different servers, they need to be accessed from the outside, so they need two different IPs on the internet. The thing is, for updating their databases, these servers need to go where? This server needs to go here, this server needs to go here to this company. They update or they change the database or they do something, some different types of updates. Now what happens is, when that happens, only this red server goes this side is the red part, this side is the blue part. So the blue server always goes to the blue company, the red server always goes to the red company. But for this to work, you actually have to tell the company firewall, you tell him, hey listen, you need to punch a hole in your firewall for this address, because I'm going to be coming as this source, so please let me come in through your firewall. Say they have strict policies, so you have to manually tell them, please open a hole for what? This source. So they do that. They're like, okay, we'll not this color, this, alright, that's fine, we'll do that for you, we'll punch in that hole for you. For what? For this address. Similarly, for this company also, they do the same for you. They open the hole for what? 20.100. We'll be like, alright, that's fine, we'll open a hole for you too. And so this server is able to go here, this server is able to go there. Can this server reach here? No, because this firewall will stop him. He's only allowing red to come in. Red is .200. Similarly, blue is only allowing .100 to come in. Eventually, this was working fine, everything is well and good, you're using everything. Eventually what happens is, these two servers that your company had, they get combined. You get your company advances, so you get new stuff in your company. So instead of using two servers now, you combine both services on one server, and you say this is .10, a new IP address on this server, right? Now it's running both services, so it needs to update from here as well as here. Now you cannot give one server two IP addresses. It either uses the red one or the blue one. If he uses the red one of his services can update from this side, but the other service will fail because he tries to go in there with what address? 20.200. But he's not able to. Why? Because of the problem. So how do we manage this? This server, when he goes to this company, his address should be 20.100. But when he's going to this company, his address should be what? 20.200, not 100, 200. This is done with the help of something known as policy NAT. It's done with the help of something called the policy NAT. Policy NAT will define in an access list a kind of traffic. We'll define a kind of traffic and then we'll bind it to an address. We'll say this address only if the access list is this. This address only if the access list is this. Right? What is my access list going to be? First access list for the red part. I'll say ACL permit IP from which host? 1.10 going to host, this will be my ACL, say 1. Then I'll create another ACL, ACL2, saying permit IP host what? 190, same, the source will be the same, 1.10, but going where? 100. right? And then I'll create a static NAT. The static NAT will say static from inside to outside. The outside address is going to be 20.200 only if the inside is not an address, it's ACL1. And another statement saying what? Static inside to outside to what? 20.100 only if the ACL is, only if the traffic matches this flow. So if the traffic is coming from 192.168.1.0 to 100.1.1.1, that will be this ACL, it will be changed where? 20.100. But if it's this ACL, it will be changed to what? 20.200. So if actually the traffic is going here, that will be predetermined on the PICs, is actually going to 200, he'll change it to 20.100. But if it's going to 200.1.1, he'll change it to this address. So your problem of that thing is solved. Policy 9. Good? Questions? No? No questions? Is it clear? Is it clear, everybody? Let's try to do that.
So the incoming packet will match to ACL.
It will be checked against the ACL. This is a separate ACL, not the incoming out. It's not applied to any interface. It's only used for matching the traffic, just like in your VPNs. You have traffic match address, this is just like the same. Match address ACL, this. If it matches, then change the source. Right? The original AC, the original static, I'll keep it as it is. In my topology, I'll do it like this. Now, first let's remove the previous ones. So clear, configure, static, all the statics, clear, configure, access list. Right, so I remove this junk, clear it off. Now my job is, say, for example, this guy. I'll have two addresses on the outside. One will be 200.1, which is there. The other will be 300. 300. So I'll have interface loop back 100. IP address will be 100.1.1.1. ठीक है? Done? Routing नहीं ज़रूरत है. This is on the internet. Everyone will come in as the default router. ASA will be able to go, right? 100 पे भी जा रहा है, 200 पे भी जा रहा है. Right? Everyone will be able to go here. I have no static, I have no natting command right now, so that's why it won't happen. But when I do natting, it'll be able to go. If ASA can go, everybody else can go, because everybody will be natted onto the ASA's address. Right? My job right now is R1, say this 1.1. 1.1, if he's going to 200, will be should be changed to 150.1.20.200. But if he's coming to where? If he's going to 100, it should be changed to this address. Which guy? This one guy. And something in the middle of this and this. 1.1. So if it goes here, it'll be red. If it goes here, it'll be blue. If it goes this side and this side. Alright? Let's try how to do that. Same thing. Create an access list. I'll call it 1.1 going to 100, or let's say R1 going to 100. Just the name of the access list. Permit IP host 1.1 to which guy? 100.1. The other one I'll create is R1 going where? 200. Permit IP host, the source will be the same as 1.1. The destination will be 200. Two different ACLs, one defining the traffic going this side, one defining the traffic going the other side. Then static inside to outside. Change the address to 20.200 when the access list is R1 going to 200, and change it to 100 when the access list is 100. When the access list is that R1 is going to 100, change the address to this. When the access list is R1 is going to 200, change it to this. Let's see if it works. Telnet 200.1.1. If I just normal telnet, it'll use the interface IP. Normal telnet. I'm not using a source. When I use the source, give it some time, going through the NAT process. Cisco. Where is he going? When I ping 200, his source became 200. The same thing, but I won't go to 200.1.1. Now I'll go to 100, the different server, the blue server now. What am I going in as? So my source there became 1.100. My source here became 1.200. Clear? Clear, everybody? Yes? That is your policy NAT. This address was changed to this when he was going here. This address was changed to this when he was going here. The last thing that you have to do today is DNS doctoring. That will finish your NAT. The whole of NAT. But guess again, you'll have to practice, yeah? What?
8.0.
8.0. Only on 8.0. 8.4 we'll do later. But I won't do that immediately. Because if I do that immediately, you'll forget both immediately. You'll forget both. You'll learn both quickly and you'll forget both immediately. So I'll take a break. I'll finish the rest of the topics. Then I'll come back to 8.4. Why? Because at that time, before the class, you'll have to practice all of this. So it'll be a double memory refresh for you. Right? Just like we're doing with the VPNs. Right? So what we are going to do is, this is good. Last thing you have to do is DNS. Now this, you won't be able to practice or test. You just have to know the concept. It's just like QoS. You just have to know the concept, and it's just one keyword. One keyword, but understand what it does. The problem, and this is real life problems, these occur a lot. This type of problem occurs a lot in real life because a lot of people don't know how to solve this. I actually had people coming up to me when I was teaching in Pune. I had people coming up to me, they brought me this problem. Sir, we have this problem, how do we solve this? The case is pending from 4 days. And the guy is not agreeing to what I am saying. He does not have money. This is a solution which will get you out of the problem, but it's not a recommended solution. But if you're in a problem like this will help you at that time. Let's look at the problem. I have the firewall, right? Connected to my internal PC. This is my client on the inside. On the LAN, 24. Good. So it's connected to the internet again. On the internet, there is a DNS server. There's a DNS server. Good. Now the thing is also, at the same time also, I have a web server here. A web server here which is 192.168.1.100. and I am 1.1. I'm hosting this web server on the outside using the command static inside to outside and 20.100. The inside address is right. So this server can be accessed on the outside. How? Which address? 20 dot. Good. This is normal what we've been doing until now. The thing is, say this is the internet, right? There's a guy on the internet connected to the internet. He wants to access this web server. Right? Now he won't, when you access the web server, you just don't go in there and say something like this. You don't say 150.1.20.100. You don't do it like that. You type in an address. Right? You type in an IP, you type in a website address to go in there, www.something.com. So that's what I'll do. I'll go to the DNS server whenever I'm creating this. I'll go to the DNS server, I'll tell him, hey, put in an entry. In that entry you say the 150.1.20.100 is actually www.munibsha.com. So whoever on his website entry says www.munibsha.com, what happens to that packet? Does it go straight here? No. The first thing that happens is a DNS packet is created. Right? Yes. Say 8.8.8.8. This is the DNS server. 8.8. Google's DNS server. The destination is Google's DNS server. And he's basically asking him, who is munibsha.com? Right? The packet goes where? To the DNS server. The DNS server replies with what? The IP address of him. He tells him that the IP address of munibsha.com is what? 20.100. So the next packet that he sends it how? The packet looks like this. From his source, whatever is the source, XXXX, the destination will be, and this packet will come in through the firewall, go in where? To this. This is how normal DNS services work on the internet. Right? The first packet does not go to you. The first packet is a DNS packet going to the DNS server. A reply comes back in with your IP address, and then he sends the packet to you. The firewall will have obviously an entry from outside to inside for this address. Now the problem may occur here. This is the problem. This was just how it works. The problem may occur if, see, normal people can access it. If people on the outside, they can easily access it. How about this? If this guy wanted to access this server,
inside there.
he's inside. The server is on his LAN. What are the ways to access him? One way is he can just go to his browser and type 192.168.1.100, which is one way of doing this. For testing purposes, he wants to test if the website is working. He can do this. But some people are reluctant. They don't want to do that. They'll call you up. They'll say, hey, no, why will I do like that? I want to do it just like it happens on the real internet. I don't want to do it 190 to 168. I want to see if it's working from outside. So I want to do this www.ms.com, munibsha.com. We want to do this. I want to see it should work. Now when he does this, what happens? What is the first packet that leaves? It's a DNS packet. DNS packet with the destination of 8.8, right? And his own source, 190 to 168, whatever it is. The packet will go out, will be patted on to the pat address, right? Reach whom? The DNS address. The reply that he gives him, that is what I worry about. The reply that he gives him. What address does he give him in the reply? 150.20.23. The reply comes back here. Who does he send the packet to then? 150.1.20.3. He sends a packet out 150.1.20.3. The packet goes out with the destination of 150.1.20.3. It hits firewall on what interface? Inside. The destination of the packet is, the source is 1.1 and hits on this interface. He checks the interface. Which interface does he hit on? Inside. The inside should be what? 192.168. He should change the source, right? He changes the source to 100. He changes the source to 150.1.20.100. That's all he does. That's all he does, right? He's not, basically what he should have done was, he should have received the source as 100 and changed it to somewhere else. But right now, nothing matches in this statement. Does anything match from this statement for him? Nothing matches. Yes, if there's patting happening, then patting matches. So it becomes this 20.100 going to 23. But 23 is no real address. 23 was the NATed address of this guy. He would have done that if he had received it on the outside interface. Then he would have changed the destination. Here he cannot change the destination of the packet because it's been hit from inside. If he could change the destination, he would make the destination as 192.168, 1.100, and the packet would leave. But here he does not have the capability to change the destination of the packet. So it's dropped. The packet is dropped. Do you understand why? You understand the problem that occurred? The DNS reply that was sent to him. In the DNS reply, it said it gave him the public address of the server which is right next to him.
Okay.
So when he sent the packet out, he should have sent it directly to him. But he's sending it out at the public address. And it hits firewall on the inside. On the inside, he cannot change the destination. He could have changed the destination if that packet was received from the outside. But it's being received on the inside. On the inside, he cannot change anything. So he drops, the firewall drops the packet. And this guy will never be able to reach whom? If he uses ms.com. Unless. 3 solutions of this problem. 3. One I told you already. One is he just uses 192.168 1.1 in the 1.100 and he uses the server directly without going to the DNS server. The second and the most widely used one is which one? To have an internal DNS server. Don't use the public DNS server. Have an internal DNS server here which resolves this for you, which resolves ms.com for you. So the ms.com will go here. He'll tell you it's 192.168.1.100. You'll throw it out here. You start out going out to the internet and coming back in. You do it. LAN के अंदर ही हो गया ना. So that's fine.
So that means get entries about website that the local DNS doesn't know.
Yeah. If he doesn't know, then he'll forward it out. If he doesn't know, you can configure it to use 8.8 also. This DNS server can be configured to use 8.8 if he doesn't know that address. But at least this problem is solved. If MS, you will know. ms.com, he'll know. So he'll resolve ms.com for you. But others, he'll go to DNS server and give you the actual address to go out. That is the good solution out of this. But this is where the people are reluctant. They want the solution to be solved on spot. They don't want to buy another server to do this. In that case, what do you do? In that case, what you do is you don't do this. In the end of this command, you write this statement called DNS. What does this do? This DNS, now remember this very carefully, it only checks DNS replies. But all of the DNS replies which will come into your network now, all the DNS replies that come in, he will check them. The firewall will open all the DNS replies and check what is inside that. And he will look for what address? This public address. If someone is getting this public address as a reply, he will also change that to this. Let's see how it works. He does www.ms.com. A DNS packet is sent. This is just a DNS packet going out packet, he doesn't check. The packet goes to the DNS server. DNS replies. What is in the reply? Which address? 100. The public address. Right? The reply comes in, hits the firewall. All DNS replies he's going to check. He's going to check if the reply is 120.1.20.100. Right? That is a problem. Why? Because he will never be able to go to 20.100. So what he does is he changes the reply of the DNS. Changes the DNS reply to what? To this other address, which is, and forwards that reply in. Then he sends his packet where? He doesn't send it to 150.1.20.100. He sends it straight to this guy. Sends it straight. He checks all the replies. Is it efficient? No. The firewall will have to do a lot of work now. He's already doing a lot of work. Now you're giving him more load on top of that. He's doing natting, he's doing patting, he's protecting you from attacks. On top of that, you're telling him to open all the DNS replies, and you know how many DNS replies come in from the internal network.
The whole traffic.
It's all DNS. HTTP traffic is all DNS in the beginning. You're telling him to open up all the replies and see if someone is trying to access the internal network. For those replies, change the DNS reply from here to here. Is this understood?
Can you repeat the last part? What's happening when .1 is sending the request?
.1, this one. He's sending the request,
To
a
the
DNS reply. He's asking him who is ms.com. Right? This guy replies, says ms.com is 150.1.20.100. The public address of this server. The public address of this server, which is specified in this command, right? So when the packet comes in the DNS reply, what is the address? It says 150.1.20.100, right? Because his job is to give it to him so that he can send the packet to 20.100, right? But when it comes to the firewall, he checks that the resolution that someone will actually, if he receives this, he will try to go to 20.100 from the inside, which I'll block. Right? So he removes that 20.100 from that reply and puts in the actual LAN address, which is 192.168.1.100. So when the packet is received by him, he doesn't go to the public address of the guy, he goes to 192.168.1.100, which is right there. So he doesn't need to come out from like this, he goes straight like this. Not from the public side, straight from LAN. Because he has the original address now. Good?
The DNS server you're talking about, will it also be used as a CSM?
Why would you need it as a CSS?
I was wondering
Certificate authority, you don't need it here. This is just normal DNS. Certificate authority you need when you create VPNs or SSL VPN or something like that. This has nothing to do with anything like that. But yeah, in a company you do usually have. Internally you have servers running. You cannot run a company, a good company with safe security, you will not run it without servers, internal servers running. HTTP, not HTTP, usually DNS servers you have inside. It's preferable to have DNS servers inside. And obviously DHCP server will always be there. Good? 20 dot? This one? 23. I don't know. This is wrong. Yeah, this is 100. This is 100. This is 100. Not 23. Okay? Clear? Clear? All of it? This is DNS doctoring, and it finishes your NAT. All of it. But it requires practice. I know it's a lot. But again, if you practice, it's like 10 minutes for each. 10 minutes here, 10 minutes here, 10 minutes here, and it's done. Right? Try to finish it today. Tomorrow we'll start with context. Then you'll have 2 days off to practice both. Right? But I'll prefer if you practice today. If you get time after the match. You'll have tomorrow also. Right? See you guys tomorrow.